In this question, we use the integral test to determine if it converges or diverges. Okay, so the generic term here, an is whatever we have here, e raised to 1 over n, everything divided by n square. To use the integral test, we let the function be this, just replace n by x, so e raised to 1 over x divided by x square. Okay, now we need to show f is continuous, positive, and decreasing, all three on the interval. Look at the sum 2 to infinity, the sum n equals 2 to infinity, so the function should be continuous, positive, and decreasing on 2 to infinity. Okay, let's look at the continuous. X square being a polynomial continuous, exponential function is also continuous, 2 to infinity, we don't have 0. Okay, so no problem. And the ratio of two continuous functions is also continuous. At the same time, for x bigger or equal to 2, this is positive, and exponential function is always positive, so the ratio of two positive numbers is also positive, so this is good. Now to show this function is decreasing on this interval for x bigger than or equal to 2, what we have to do is find the derivative of this function, use quotient rule combined with chain rule, and show that, find the derivative and show this derivative is negative, the derivative is less than 0 on 2 to infinity. Then by calculus 1, we know when the derivative is less than 0, the function is decreasing. But to show f is decreasing, let me argue in this way. Okay, when the x is very big, which one grows faster, the bottom or the top? Let's take x equals 100, so this will be e raised to 1 over 100, and 100 is squared. Even x equals 1000, e raised to 1 over 1000, 1000 is squared. The bottom, x squared, grows faster than the top. That means this fraction is decreasing. Okay, so the fraction is decreasing for all x 2 to infinity. Now for the integral test, then we find the improper integral, in this case 2 to infinity of e raised to 1 over x divided by x squared dx. And to evaluate this, we write in terms of limit 2 to t, and let t go infinity, e raised to 1 over x, I'm going to write in this way, and 1 over x squared dx. Okay, now to evaluate this definite integral, e to the something, that's the inner function, so 1 over x, let's say u, then derivative of 1 over x. What is the derivative of 1 over x? 1 over x is x raised to negative 1, and find the derivative, it comes out to be negative 1 over x squared. Okay, there is no negative sign, but we can put always negative, multiply by negative 1 and multiply by another negative 1 outside, so negative times negative positive. So if we let 1 over x be u, then negative 1 over x squared dx, this becomes du. So basically we have antiderivative of eu du, so we have this situation, e to the u du, and we know this integration, this is just eu. Okay, so negative all the way outside, negative 1, limit t goes to infinity, antiderivative of eu du is eu, u is 1 over x, and we want to evaluate from 2 to t. Okay, let's evaluate this function at the upper limit minus lower limit, negative 1, limit t goes to infinity, upper limit replace x by t, so e raised to 1 over t, minus lower limit e raised to 1/2. Okay, now let t go infinity. When t is infinity, very big, 1 over infinity is 0, e raised to 0 is 1. So when t goes to infinity, e raised to 1 over t goes to 1. 1 over t is 0, e raised to 0 is 1. So negative 1, this goes to 1 minus e raised to 1/2. When we distribute this negative 1 inside, negative, negative, positive, so let me write e raised to 1/2 first. Negative 1 times 1 is negative 1. And this is a positive number. Square root of e is about 2.7 when you take a square root. 1/2 means the square root. This will be bigger than 1. In any case, this is a finite number. That means this improper integral converges because we have a finite number. Since this improper integral converges, this series, the corresponding series, converges. Okay.